So let's start with the Alice and Bob, the two-way relay, right? And this was one of the first papers where network coding was mentioned. I think it was 2 years before the actual Alswede paper came out. It was an early VTC paper by Ericsson, and they just had Alice and Bob, where Alice and Bob were two mobile phones, and the guy in the middle, the relay, Charlie, was the base station. So what does it do? You see here Alice and Bob, and they would like to communicate. This is the logical path, right? But from the wireless perspective, they don't reach each other, so they need the relay. So what will happen in store and forward networks is Alice will send something to the relay. The relay will send something to Bob. Bob will then answer with something to the relay and back. So if you think in time slots or capacity whatsoever, there are 4 time slots for the exchange of an information between Alice and Bob. Now, what can network coding do here? And you see already the colors that we have: blue, yellow, green. It's the same idea, right? Now, Alice and Bob will send something, first Alice, then Bob, to the relay. The relay has 2 packets. We'll combine them, feature the XOR functionality, and broadcast it. By broadcasting, you only need 1 time slot. You just send it out. And with that, you get a gain of 33%. Again, 2 packets. Now, if you understand Alice and Bob and also the butterfly, then you see here the source, 2 destinations, and that you have 1 source could be also that you have 2 different sources with something. And you can morph the butterfly example one by one into an Alice and Bob scenario. Okay? So you need only 1 XOR in that. Now, this XOR idea was so intriguing to us that we said, okay, let's perform that. And what I will do now, I will give you examples, not how great we did it, we show you where we failed. So with the pitfalls, we understood what is working and what is not working. This is part of theory that matters, right? So we created a project together with Morten Petersen, the one who also was the originator of Kodo. We said, let's look into network coding with this magic XOR. And you see here exactly the same stuff, Alice and Bob, but in a different way. The initial packets will come from the base station A, B here, and then they exchange. And here you see on the right the network coding part. And this was, at the same time, there was XOR in the air, a paper by Muriel, very nice. We'll come to that as well. And this has similar ideas. Nevertheless, this was implemented on a Symbian platform. And what you see here are 3 different phones. And what the green one, the display of what we send out and what we receive. Green means it's my own packet, red is what I got. And blue means I will code that. So the coding is interesting. So when we did this, we were expecting a lot of blue packets that should come in. Now, it never happened. So we thought we are sending the packets, you should get the packet, you do the XOR, you broadcast it, and you get the blue ones. And we looked over this and we were discussing why it's not working, and suddenly we had these 3 packets that came in. 3 packets, the first 3 packets that we ever saw that were coded on a Symbian platform. So we made a screenshot, and nearly we missed it, as you saw. And you see there was a lot of greenish packets here. So something happened there where one side was sending more than the others, and suddenly we get coded packets. So the lesson was, it's important to create coding potential. What does it mean? What happened later, we saw that we had a very nice architecture where the packets come in and out, and it was like he was sending and he should also send, but he was so quick in sending it out, he did not code. So by simply having a timer to say, wait a little bit, right? Wait for a certain moment that the other side has the chance to send you a packet, we created coding potential. But you should not wait too long, right? So then you will wait for hours. How long should you wait? And alone this finding the timer here to say when should you stop waiting and just forward it is already part of research. For a long time we did this. So what you also see here is an energy profiler where we really were looking into the energy, what the coding did, because later we will talk about this as well. It's not only about the efficiency, we are doing something now. Before that it was just take the packet and forward it. And now we also compute. Compute will also eat up the energy. That is the cost. But in general, and we can now take this for the next 10 10 lectures whatsoever, it always paid off so far to invest energy on coding and not on the transmission. So what you see here is an example that also others did. This is the DLR. You can see, you can go to their webpage. What they did is they wanted to have Alice and Bob. So they have 2 ground stations, they have 1 satellite. What they said is, okay, let's send packet A and B up there, and he should XOR and send it down. The problem was there was no computing power over here. So what they did is they sent the packet up, sent all packets down, the XOR was on the ground station, send it up again, and they will broadcast it. So this was stupid from the efficiency, but they just wanted to prove that the concept works. So what they're doing now is they want to replace satellites from store and forward to more intelligent entities. And if you know about SDN, ICN, NFV networks, need some computing power in order to perform. And this is what they also should do. And then the network coding part will be easy. Good. That was Alice and Bob, right?